Hey guys, in this video lesson, we're going to go over the DVD logo sketch and we're going to add some improvements to the actual way that the DVD logo is navigating around the screen. We're going to go through some of the code. We're going to explore those conditionals again, making sure that we understand the structure of the program that we've written so far. And then we're going to introduce a new function that's going to enable us to load image assets in a little bit of a different, more optimized way. So if you're not already there, please get into your Stack Starter environment and let's get into our editor. And I'm going to go ahead and also run the sketch. So far we should have this. Now if you don't have this, I'm going to include a link to this code in this assignment. So you should be able to just simply copy and paste the code if you're not there and paste it into the DVD logo .js file and be able to get here. So we have an image bouncing around the screen. This looks pretty good. And actually it's a little small on my laptop screen here as it did on the projector in class. We could go ahead and adjust the size if we wanted to. But there are a couple of things that are happening here. The most apparent being that the DVD logo is coming to the edge of the screen here on the 0 side of the screen, the left side of the screen, and the top of the screen, it's hitting perfectly, but then from on the right side to the bottom, it's kind of bleeding over the edge of the browser window. We want to fix that. We want to make sure that the DVD logo does not go off the screen at all. So think about how we did that when we were just drawing simple geometry to the screen. We drew the rectangle, right? In case we were drawing a square. And the reason why we had to basically fix that is to offset because of the fact that the coordinate system locally for the logo or for the square is in the upper left-hand corner, right? So 0, 0 or x0, y0 for the image is right in the corner here. So if I go here into the code and say, for example, I do not animate this, so I could just give you a bit of a better visual. So I just fixed the image on the screen. The 0, 0 point is right here in the upper left-hand corner of this image. It's not in the center of the image. So when we're testing whether or not the image is all the way to the side, it's going to detect it's all the way to the side when it gets to that point of the image. So if we say that, for example, if we say that the position of the image is, this is the X, this is the Y, right? So the X is the horizontal plane in the grid. So if we say this is the window width, right? Let's see what happens. You're not going to see it. Right? It's actually plotted over here off the screen. The X position is window width. But now, if I say position this at window width minus the width of the image, which here we're calling the image function, right? So we call the image function here. Right within our draw function. And the first parameter is the image object, which is the image variable, that bucket that we've created to store that bitmap data into a variable for us. And then we're passing that to this image function, which then is responsible for actually drawing the image to the screen. Then we give it its position, and then we give it its width and its height. In this case, the width is 100. So if we're drawing it in 100 width and 0, 0 is in the upper left-hand corner, all we have to do is offset this by the width. And now if we do that and we refresh this, we'll see that the DVD logo is butted up right to the edge of the screen. Now we can do that same exact thing with the height. So if we wanted to draw this at the height and say window height, what we would expect here is that we're not going to see the DVD logo because it's going to push itself off the bottom of the screen. So if I go ahead and refresh this, we don't see anything. the DVD logo is all the way down here. So what do you think we need to do that? We're going to do the same exact thing that we did to the window width. We're going to offset it by not the width, but now the height, which is 58. So we'll go ahead and subtract this by 58. Okay, awesome. Let's see what happens. So if we go ahead and refresh this, boom. Now the DVD logo is buttered up to the right side of the screen, or the width of the screen, and buttered up to the height of the screen perfectly. Excellent. But it's not moving. What the heck? So now we have to go ahead and animate it. So in order for us to animate it, we're changing this variable on every frame, right? The XPOS and the YPOS, these two variables. Really, all of this logic comes down to these two statements that allow us to calculate exactly where we're going in terms of the position of the image. So in order to actually get this to animate, instead of doing window width and window height, we're going to change this back to XPOS and YPOS. Now with this line of code, I'm going to go ahead and just take this rectangle call out here. We don't need that anymore. Now with this line of code, we should be able to see that the DVD logo bounces around the screen, and when it hits the corners on the left side, we'll have to wait a minute here because it's traveling. Whoa, it went all the way up. Why did I do that? Ah, look at that. Now it bounced, but now the top and the other side is offsetting. We don't want that to happen. Actually, looks like it's a little bit off too on the height. Interesting. So now, if we think about that for a second, we are drawing this at a position minus 100, right? And YPOS minus 58. So instead of doing that, actually, we actually still have in our code here in these conditional statements, these offsets here. So we can actually go ahead and take these out, or we can adjust them. So this may actually be a better way to do it. So we offset this in the drawing of this. So when we're drawing this at X position 0, say for example, this calculates to be 0, this is why when we're at the 0 position, it's going to go to negative 100, right? Because 0 minus 100 is negative 100. So this type of strategy is probably not the best strategy to take because it's going to fix one side of the screen, but then break the other. And this is something that happens in development a lot. We call it regression. So whenever we're trying to fix one thing, we fix another thing. In reality, when you're doing this in practice, and it gets bad, it could be you fixed one thing and broke 5 things, which is not a good thing, right? So there's a lot of things in larger projects, people write other software which are actual tests to test the code. So in this case, we just regressed, right? We solved one problem just to create another. So we don't want to do that, right? So instead of offsetting this when we draw, maybe we should test for the offset in the conditional statement itself. So let's go ahead and take these out. Now we're back to the same problem. So now if we go here, now we did not solve that problem of the DVD logo on this side. It's going to go over. But now the top of the screen should bounce perfectly, and the left side of the screen should bounce perfectly. Let's see what happens. Boom. Great. Now, what we want to do is when we test, so we're testing the right wall, we're testing the left wall, which is 0, we're testing the top wall, which is the top of the screen, and the bottom, which is the bottom of the screen. And really the walls that we're concerned about right now are the bottom and the right? Those are the ones that are going over. So if we just focus on the right wall first, we're testing to see if the X position is greater than or equal to the window width minus 20. So we're saying once you get to the window width, but then we're subtracting 20 from it. So instead of 20, why don't we put the actual width of the image, which is 100, right? So we're going to put 100 here. Now, one thing we can do too, notice how we've duplicated this 100, right? So if we change the size of our image, we need to change this 100 in two places. Whenever you see this in code, that normally calls out to you in terms of, hey, this should probably be a variable. So we would have to only change it in one place to be able to actually change that value in multiple places. So what would that look like? So right after the background black, we could set a new variable and we could say let the image width equal 100 and let the image height equal 58. Now, in place of these fixed values that we've created, we can put in image height and image width. So we'd say image width for that and image height. Now, when we offset by 100 here, we could say minus the image width. Again, when you're writing this stuff, and as you become more fluent in writing this, it starts to read like English, and readability in your code is really an important thing. So if we read this function call, we can see we're calling the image function. We're passing in 5 parameters: an image variable, the X position, the Y position, the image width, and the image height. And now when we're testing for the right wall, we're saying if the X position is greater than or equal to the window width minus the image width, which you got to make sure you spell image right here, as I did not there, then we'll go ahead and change the direction. So let's see if that right wall is actually working. So if we go ahead and refresh this, uh-oh, something's not working. That's not good. We're just bouncing around the bottom of the screen. But if you noticed, the right wall actually did work. It did bounce properly, but it's not going up. So let's see that one more time. We're traveling down here, we're traveling down here, we're going, and boom, that looked good. But we never actually went up. So let's see what happened here. So the X position, window width, window height. Just going to go ahead and take this out for a second. There's a little live coding session. We'll see what happens here. And now we're animating. So it doesn't like that offset. So that width is not flowing with this. So if the window width minus the image width, where the image width is equal to 100. The X position minus the window width. So let's try something different. Let's see if we go minus 50 here. We'll take it and put it in half. In this case, I just made up 50. I took it and basically split that 100 in half and see what happens. Now we're going off the side, but I'm curious if we go, okay, we're going all the way up. That's offsetting. So let's go back here. And let's change this to 100, which is the value of the image width. So I would expect this to do the same thing that was just happening where it was bouncing along the bottom. Good. So that is doing that. Now let's see if it's any different if we do this. It should not be any different, right? We should get the same results if we say the X position minus 100 is greater than or equal to the window width. It looks like it went way off the screen. So is it possible that I'm just having an error here with the logic? Is it the window width? We need to offset it from 0, 0. So I think we just need to do plus instead of minus, right? So if we go here, we say plus image width. Oh, that's no good. No, because that's going to make it even wider, right? So if the window width is 100 and the image width is 100, then we're testing to see if the X position is greater than or equal to 200, right? That's not going to work. So it's this kind of debugging that is something that, as you're doing this is kind of the flow of what's going to happen. So I'm glad this is happening, and some of you playing along may actually see what the issue is already, right? So let's go ahead and take this out. Take it out completely, and let's say if the X position is greater than or equal to the width of the window, then bounce. And let's see how this works without any offset. So we would expect it to go off the side of the screen just to that 0, 0 position, which it looks like it did. And look at this. Boop. Yep, so it did do that. So if the X position plus 100, right? So if we add 100 to 2, which is the width of the image, greater than or equal to the width, I think this should work. Boop. There we go. So where we put that operation does matter, because by putting it in the window width here, we're actually extending the width of the window, right? By doing this, we're saying that the width of the window is whatever the width is plus 100, which is only going to push that image off the screen that much more. By putting the X position and basically pushing this forward the width of the image, now the window width is still is the right window width. There's no offset there, but we're moving the X position forward to where it actually is to do the test. So think about that for a second and maybe really study this conditional that's happening here. We're taking the X position, which we're testing in the upper left-hand corner of the image. We're adding the width of the image to that and then testing to see if that is greater than or equal to the width of the image. I know that might be like a complete, like, what is going on? What are you doing? Right? But pause it for a minute and think about it. So what we can do is we can take this 100 now and use the variable we created. And now it should do the same exact thing. Boom. Nice. Now our bottom is doing the same thing, right? So think about how we would solve the same issue, but for the bottom wall, right? We're saying that the Y position, if the Y position is less than or equal to 0, then change the direction. So what we can do is we would then take the Y position and add the height to it, right? So we go here and say plus image height, which in this case would be 58. Now let's go ahead and see what happens. Not good. Doing the same thing. We're just bouncing around that wall over there. That's not good. So we want to take that out and let's go through the same process. Let's say, hey, if we take the Y position plus 20, right? So if the Y position is 0, or say it's, well, is this the right wall though? So is this the bottom wall? Less than or equal to 0, because the Y position is up or down. So if it's less than or equal to 0, that means it's hitting the top wall. So this is actually the wrong comment here. This is not, this is the top wall, not the bottom wall, right? Because the Y position is less than or equal to 0. 0 is at the top of the screen, not the bottom. So this is the bottom. That is not the right comment. That must have changed when we were moving stuff around in class. So that is the bottom wall. And now when I share this code with you guys too, it'll be the updated code after this. So I'm not going to have these little commenting issues in it or anything like that. So now this is actually the bottom wall, right? Where the Y position is greater than or equal to the window height. Minus 20. So we're going to take that minus 20 out because that's from when we did it with the square. And we're going to say the Y position plus the image height. Now we're moving that Y position from the top left corner of the image to really the bottom left corner. And if you've taken the width here, we're actually moving it to the right when we test the XPath. But in this case, we're just moving it to the bottom for this conditional. Now, if we run this program, when we hit the bottom, when we hit that wall, boom, boom, now it should be bouncing all nice. Boom, boom. Beautiful. Excellent. We got it to work. So take a moment and play around with that a little bit. And see if you can get this to work. The key point here is that we are offsetting where the current position is to the width and height of the image due to the fact that the local coordinates of that image, the origin point on that image, is in the top left-hand corner. So in order for us to test the right side of the image and the bottom of the image, we need to offset it by its width and its height. The other thing we did here was we changed the program to use variables for the image width and image height. So if we wanted to change the image width and image height, say for example, we wanted to make the image 200 by 158. Now this is probably going to destroy the aspect ratio of this image, but it should change the look of the image or the size of the image. So if I go ahead and refresh this, now the image is bigger and it should also offset properly. Look at that. So we didn't have to change the offset in any way, shape, or form. We just had to change those two variables. So by using variables, we're literally creating little configuration knobs in our programs. You can literally visualize these as knobs, like if those big soundboards that maybe some folks at 5 Towns are learning, those little tiny, those hundreds of knobs, that's really a value, right? That gets fed into some system that is basically a variable. All right, so we just created little knobs in our program. Awesome. So this is looking really good. Now, actually, I want to make it a little bit wider. Maybe make this 230 just so that the ratio looks a little bit better. And look at that, 230 doesn't work. That is interesting. So if I go to 200, it works, but 230 does not. So there is still some type of logic error in what we're doing here for how we're testing the image width and image height. Interesting. So if we go back to 200, it works just fine. Okay. Well, we're not going to concentrate on that too much right now. That's not important. One thing that is important, though, is the fact that we are loading this image inside of our setup function. Okay, so we're going to get off of the conditions a little bit right now. We're going to shift gears to bringing in assets or images into our sketches, into our programs. So the way we're doing this in the setup function seems to be working, but if this image was any bigger than it is, you would see a noticeable lag in the image being displayed in the sketch. So in order to fix that, oh, look at that. It's, oh, you know what? I know what the problem is. We are randomly placing this on the screen by width and height. If this gets placed outside of the bounds, then it will bounce around, as you're seeing here. So because of this, because of this random width, random height, our X position starting at a random place where width and height is not offset. So really what we should do is move these variables outside of the draw function and put them up where we're defining all of our other variables. So we're going to make this more of a global variable for our sketch. Now, nothing will change in your draw function, but we would say instead of creating a random variable to the window width, we'd say random variable to the window width minus the image width and minus the image height. This way that we know we're generating the image within those bounds itself, not any larger than the bounds that we're testing. So if we do that and refresh this, now it will only generate within the bounds of the screen. I know this may seem rather confusing, and many of you may be cross-eyed by this time in the lesson, but luckily this is a video lesson. You can kind of pause it, back up, and kind of listen to it again. But now, no matter what we change the size to, so if I go ahead and change this to 220, it should be okay. There we go. Okay. So, being that we are loading the image in the setup function, that means that the sketch is creating a canvas before it loads the image. So if this image was huge, it would take time to download, because remember, we're working on the internet. This is web-based stuff, right? So the web requires us to download the images that that the browser ultimately is going to present to users. So what's happening here is we're creating the canvas, we're drawing it to the screen, and then we're going ahead and trying to load the image. And then right off the bat, we're going in and starting to draw frames to the screen. So what's going to happen is, if the images are not downloaded in a fast way, the user of the application is not going to see those images immediately. So that's going to cause screen flashing and undesirable results for our users. We don't want that. So what I want to do is I want to introduce a new function. Right now, we've only really been using, or really defined only two functions. We're calling a lot of functions like the fill function, the image function, the background function, and things like that. But we've only defined two functions, the setup and the draw. We're going to go ahead and define a new function that is part of P5 called Preload. And I'm just going to go ahead and pull up our handy reference for Preload. So if we go here and go into our reference and we just search for Preload. Now this function is pretty simple, and it really is a simple change to our program to ensure that we load images first and then we set up our function. So I would recommend that you guys spend some time on this page and really take a look at this code and read some of the descriptions on this function. This function is really helpful for loading images and things like that before anything actually executes. So what we're going to do is we're going to go ahead and define a preload function in our sketch, and we would put this before the setup function. And this is because we're going to read this top down and we want to see what's going to get called first, second, and third. So I'm going to go ahead and define a function called preload. Remember to open our curly brackets. You hit enter, the curly brackets will automatically close, and our cursor will sit exactly where it should be for us to type. It's going to indent for us nicely. So what we can do is, instead of doing the load image in the setup function, I'm going to say img equals load image images / dvd logo.png, which is basically the same line that we have here. I'm going to go ahead now and also take out this line from the setup function. Boom. Now, by making that small change, what's going to happen is the first function that's called, the first function that P5JS will call, will be the preload function. And I'm sure a lot of us have seen this when we play video games, or maybe we go to a really interactive website and we see a loading bar, right? you can see, the loading bar is basically saying, hey, we're loading all of the digital assets we need in order for us to actually render the image to the screen or the interaction to the screen. We see this more in video games. It's not really a desirable effect on websites today. It used to be back in the day when we did a lot of Flash development, but now users are very, we don't want to sit there and look at a preloader. And if you're going to create an experience like that, I would argue that it's got to be a pretty solid interactive experience if you're going to make your user sit and wait on a preload. But in this case, the preload really shouldn't take that long because the images and we're really loading only one image. And we didn't really see that much of a performance impact by just doing it in the setup function. So I'm just going to put a little bit of space between this so we can read it a little bit better. Now, if we go ahead and load the sketch, we really should see no change. It's going to operate exactly how it was before. The only difference is that the preload function is getting called first, and the setup function is waiting for the preload function to finish loading all of the assets that we told it to load. In this case, the only thing we told it to load was this single image, which we're storing in this image variable. So take a look at this function, and there are a couple other preload type functions and load calls actually that we would put inside the preload function. For example, we're using load image. There's other ones like load JSON, which is a data structure for loading data across the internet. Load font, say for example we wanted to load some cool fonts into our sketch, or load strings. Load strings is more for like a text file or other type of data, like maybe a CSV or Excel or something like that. Okay, so now we have a preload function, we've got a setup function, and a draw function. So now we have 3 functions that we've defined within our sketch. Awesome. This is looking pretty beefy. We've got a good amount of code here. And we've got a good amount of logic going on here as well, right? This is looking good. Now, one thing that's not happening, that was happening when we did this with a square, was the DVD logo is not changing colors when it hits the edges. We want to change colors, right? So how do we do that? Now, when we did it with the square, we used this fill, right? So every time it hits a wall, right? So it hit the right wall here, it does a fill. And then it hit the left wall, it did a fill. It hits the bottom wall, it does a fill. It hit the top wall, it does a fill. Now, why is the fill not doing anything for us right now? Let's take a look at the fill function's reference. So the fill function sets the color used to fill shapes. So think about that for a second. When we drew a square to the screen, we were able to set the fill and the square changed color. But when we're drawing an image to the screen and we set the fill, it does not change the color. The reason being is because we're not actually drawing a shape to the screen anymore. We're drawing a bitmap. We're drawing really a table of pixels to the screen. So by setting the fill doesn't know what to actually fill because there's no shapes to fill it in. You could think of a shape in this example as maybe like a cutout where we could just pour paint into with a fill color. But an image is not that. An image is a table of pixel data for us to draw to the screen. So that pixel data, each pixel has its own RGB value, right? So we need to be able to modify each individual value in those pixels. Now, there are pretty complicated ways to do this, and in more complicated image processing programs, we can write software to actually iterate over this really two-dimensional table of pixels. But luckily, P5.js has some functions already available to us. So one function here is Tint. So the Tint function is something that allows us to basically adjust the RGB values in a bitmap. So if we go ahead and look at the description of the tint function, it sets the fill value for displaying images. So images can be tinted to specific colors or made transparent by including an alpha value. So if we look at the syntax here, we could say, all right, give tint 3 values, which would be your RGB values, and some alpha value. Or we can give it a color object or just a straight value to make grays. In this case, we're going to use it the exact same way that we were using the fill function. So it's really the same as the fill function from a syntax point of view, but we're just changing the way that we're manipulating the output. In this case, we're outputting an image, not a shape. So if I go back here and to our conditionals, every time we hit a wall, we've got one of these conditionals. So instead of using fill here, I'm just going to change fill to tint. Now let's see what happens. Now we hit a wall. Boom. 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 Nice. It's working. So really all we did was we changed the fill call to a tint call. And now it's making random colors of our DVD logo. One thing I think I would like to improve here is when the sketch starts, it's always going to start on a white image or whatever the color of the image is. In this case, I want to initialize that to something else. So let's go ahead to our code here, and in our setup function right here, instead of saying fill black, I'm going to take that out, and I'm going to copy one of these tint functions here and paste it right here. So now in the setup, we're creating our canvas, we're painting the canvas black, we're randomizing the position of the actual, ultimately where the image will be drawn. So we're randomizing the X position and Y position variables. And then we're setting the tint to some random color. So now if we go ahead and do this, it'll start at a random color every time. So if we go ahead and refresh this, and just kind of refresh it a couple more times, you should see every time it's getting a different color. And now every time it hits the corners or the walls, it will change. So give this a shot. What I'd like you guys to do is get this to work. Follow along with my lesson. I apologize for some of the conditional kind of spaghetti that happened there, but I think that was helpful in some respects to show some of the debug process and see how we kind of work through some of these problems, and how in many cases, as you're moving around code, you do introduce different types of problems. We call those regressions. And it's important that by understanding and reading the code and really getting literate in looking at code, you can actually see, okay, oh wait, I have this in the wrong spot, or maybe this doesn't make any sense, or I changed this and I shouldn't have, or something like that. So follow along. We can sit here for another 15 minutes and see if the DVD logo ever hits the corner. Yeah, what I'd like you to do is once you get this working, please submit the assignment with a link to your environment so I can review it. I'm also going to open up a discussion board where if you have any questions, please post them there and we can kind of communicate and collaborate in the open. Yeah, I look forward to you guys submitting this stuff. All right, awesome. Thanks, guys.